Something new we'll find in carbon chemistry in particular is the idea of a carbo-cation. Now, we're going to look at these because it becomes very, very important we sort of understand little bits about them in our reactions, especially our nucleophilic substitution reactions, when we look at the halogenoalkanes and how we can change them into alcohols. When a reaction occurs, if we've got something that's a little bit unstable, now here I've got a nice little 3-carbon chain, so obviously it was a prop something, so let's imagine it had a chlorine or a fluorine or some other halogen on there. Then during a reaction, we've actually had the halogen leave. Now this leaves the structure looking like this, and what we actually have to find is that certain parts of the structure will try to equal or remove the effect of the charge. So they will be electron donating groups. Now in this case we can see the little red arrows coming in from these CH3 groups, and it turns out that CH3 and other chain structures, carbon-hydrogen chains, will actually be electron donating groups, and they will try to push electrons in to try to take away the effect of the positive charge on the central carbon atom. Now the effect of this is going to make it a very, very stable structure. If however we only had the hydrogens, and we see we have one hydrogen there, if we only had hydrogens around it, hydrogens are not really electron donating structures, so the stability of our carbo-cation will be affected. And this is shown in this nice little stability chart here. We can see that the tertiary structure, in other words the carbon, is surrounded by chain structures, CH3 or longers. Then it will be the most stable because it has these electron donating groups which reduce the effect of the positive charge on the central carbon atom. In a secondary structure, we have 2 CH3 or chain structures pushing electrons in, donating electrons to that central carbon, but we have 1 hydrogen, so the effect will be less. Having 3 electron donating groups is much, much better than only having 2. And if we go to the primary structure, then we only have 1. And it is not very good at all because you've got the hydrogens which basically do nothing around the carbon that has the positive charge. So when we're looking at this, if we're going to form a stable intermediary of a carbo-cation, we need to have the carbon where the leaving group is, the halogen group that is leaving the structure. It's attached, it has to be in the middle of the structure. So we tend to find that the SN1 mechanism or the SN1 reactions, more about that later, will tend to be for secondary or tertiary structures. And that is what a nice little quick check for you. So if we find that SN1 reaction is occurring, we know we've got a tertiary or secondary structure. If we find an SN2 reaction is occurring, then we probably have a primary structure. More on that later.